are you? Hope you're doing well. Today, the second lesson in N2. And today we're not going to solve question, but I'm going to discuss the parent functions, okay? So here we have the parent functions. We'll start with those parents, okay? A linear, quadratic, cubic, rational, square root, ln x, log x, e power x, ax. Okay, those are the familiar, okay, parent function. They have many applications in math, and based on understanding those functions, it's going to help me in the exam approximately with 25% of the questions, because they are depending on functions. So let's start now. The first function is f of x equal x, the linear function has an easy way to track and understand is whenever you put an x value inside the function, like 1 we get 1, 2 we get 2, 3 we get 3, -1, -1, -2, -2, -3, -3. And so that's why we call it linear, because at the end it's a straight line equation, and the domain in this case all real number, and the range also all real number. Whenever you put x, you get also y. That's it. Easy way. So this is called linear function, f of x equal x. Okay? Second one. The quadratic function f of x equal x squared. The quadratic function, we call it the parabola. Here the shape of this function is a parabola. The parabola itself, whenever you put x, you get the value of y squared. So 1, 1 squared 1, 2, 2 squared 4, 3, 3 squared 9, -1, -1 all squared 1, -2, -2 all squared 4, -3 all squared, that is what, 9. So 1, 1, 2, 2, 3, 3, 8, sorry, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9, as you can see here. So the domain x belongs to all real number, and the range y belongs, greater than or equal 0. Why, mister? Because all the value of y are above the x-axis. It's 0 and above the x-axis. So you can see here we are covering all this area. Can you see that? So that's the range. That's why we say y greater than or equal 0. One of the other forms of the quadratic function, which is negative x squared. Of course, in the upcoming videos, I'm going to explain the transformation. So negative x squared is the same quadratic function, but what? Reflected across what? The x-axis. As you can see, it's downward. So the domain remains as it is, which is belongs to all real number, but the range y less than or equal to 0. Okay, so this is the quadratic functions, the shape of parabola, upward and here downward. Let's go for the third one. Okay. Now, cube functions. F of x equal x cubed. This is cube functions. So domain x belongs to all real number, range y belongs to all real number. Why, mister? Whenever you put 1 as an example, you get 1, 2, 8, 2 cube 8, 3, 3 cube 27, -1, -1, -2, -8, -3, -27. The cube works with the negative signs. No worries about that. So it's cubed. You need to cube the number, and you keep the sign of the integer or the whatever the number, just you plugged it inside x, and that's it. So this is the shape of the cube functions. Of course, it crossed the 0, 0, the origin, and this is the characteristics of the cube function. Okay, so let's go for the next function. Function 4, which is f of x equal 1 over x. So here we have, as you can see, two major things in the rational function, which is the vertical asymptote and the horizontal asymptote. So the vertical asymptote and horizontal asymptote are lines which the function doesn't touch that line. It goes to infinity as long as it comes closer to that line. So in this case, in this function, x equals 0, we call it the vertical asymptote, because as long as you go from right and left, y goes to infinity and goes to negative infinity. And as long as you go from y to reach 0, up and down, x goes to positive infinity and x goes to negative infinity. In this case, vertical asymptote of this function is x equals 0. Horizontal asymptote of this function, y equals 0. So based on this information, I can plug in inside x all the values except domain x belongs to all real number. That except x does not equal to what? To 0. And the range y belongs to all real number, but y does not equal to 0. Remember those information, okay? And always put in your mind, okay, these points helps a lot in transformation and understanding even the inverse and the normal functions, the operation of the functions. They might help a lot, okay? See the next function. Okay, here we have now the square root and the cube root. Square root and the cube root. The square root, it has an even index, and the cube root, it has what? The odd index. What's the difference? Here, in the even index, we can see the domain is already limited from 0 to the right. So that's why domain x belongs to all real numbers? No. X greater than or equal to 0. And the same thing, y greater than or equal to 0. This is the shape of the graph of the square root of x. But also, let's try with the cube root. Cube root here, as you can see, the y and the x, the domain x belongs to all real number accepted. Why, mister? Because the odd index can accept negative numbers. So that's why I can plug inside x any number that I want, no problem. And in this case, in the opposite side, the image of this domain is all real numbers. So that's my range. So range, y belongs to all real number. So this is the square root with its graph, the cube root with its graph. Always remember the graphs. It's important in M2 to remember the graphs. Understand the graph in your head, please, okay? And the next. Here we go. Len x, log x. Len x is log base e. So both of them, they have the same graph. And check this. In this graph, this is the curve itself, okay? We have first point, x-intercept, which means log 1 or len 1 get me 0, okay? And the graph doesn't touch the y-axis, so we call this vertical asymptote at x equals 0. In this case, since x equals 0 is a vertical asymptote, so my domain x greater than 0, as you can see, and the range y belongs to all real number because the image itself, it's covering the whole graph. Yes, domain, range, and vertical asymptote x equals 0. This function is the inverse of what? Of this function, which is the exponent. We have the exponent e power x and a power x. A power x as an example, 2 power x, 3 power x. This function has a horizontal asymptote y equals 0. And that log, remember the log, we have x equals 0 as vertical asymptote. Okay, here we have y-intercept. There we have what? X-intercept. And what I have also here, the domain x belongs to all real number. Remember the range there? Y belongs to all real number. The range here, y greater than 0. The domain there, x greater than 0. So it's those functions are inverse to each other. So you can understand this. So this function has a horizontal asymptote y equals 0, as you can see here, and it has its domain x belongs to all real number and its range y greater than 0. The previous one, the domain there x greater than 0 and the range there is what? Y belongs to all real number. We have here y-intercept y 0 1. So if you plug in 0, anything to the power 0, what's the answer? Is go equal to 1. That's why the y-intercept is 0 and 1. I believe there is one more function. Yes, I'm just gonna draw that. So we have called the constant function. It's a number. As an example, let's say 5. So f of x is equal to 5. So f of x equal to 5, this is what? A constant function. What's its domain? Think. X belongs to all real number. You can plug whatever you want. But where? Nothing. You can put any number. At the end, you're going to get what? 5. So that's why It is a function, and at the same time, it will always get you 5. That's it. What's my domain? X belongs to ordinary, but I can plug anything. I can choose any number. At the end, my output is what? 5. What about my range? My range, see, domain, X belongs to ordinary number, but what about my range? Y equal 5. It's only one number because you can see the image. It's only what? One number, which is at 5. So remember this. This is called a constant function. Okay, and we call this, what's my y-intercept? When x equals 0, y equals 5. So that's it. 0, 5. It crosses the y-axis at 0 and 5. That's my y-intercept. See these information, okay? It helps me a lot in solving questions regarding functions. Okay, I believe if you memorize them with the graphs, the intercepts, the vertical asymptote, horizontal asymptote, it's going to help you to understand the upcoming videos for the functions. See you inshallah next week. I don't know, next week, maybe, I don't know. Okay, for the other part 3 functions, hopefully with the transformation. And bye bye.